So I'm going to do 4 different examples that correspond with the IXL practice, just so you can see what you need to do. And this skill involves knowing 2 different things. You need to know about both angle measures and side lengths of similar triangles. So this problem says that these 2 figures are similar, so you need to know what that means. Understanding that similarity preserves angle measures, so that even if you dilate a figure by making it bigger or smaller, the angles stay the same. So that's angle preservation. Okay, the angles are preserved. And the sides increase or decrease proportionally. So these first 2 problems will be on angle measures and understanding angle preservation. So as you can see, this looks like maybe the original figure, and they dilated it by making it bigger to turn into this other figure. This would be the pre-image, and this would be the image. So if the angles are preserved, which they have to be because they tell us that the figures are similar, then that would mean that this side length right here, or this angle measure of 102, would correspond to this angle measure. So this would also be 102 degrees. This angle that is 39 degrees would correspond to this angle, so that should also be 39 degrees. And so that this angle, which is our question mark, that angle should then also be 39 degrees, right? So the answer to this missing, right, how many degrees is the missing angle? Well, it's 39 degrees. And if we go to the next one, so here we have 2 figures again, and again we're looking for the angle measure. But this time the figure was not just dilated, it looks like it was also rotated, right? It was rotated around to become this image. But it's still, you just want to look at how it was rotated. So it looks like it was rotated about 180 degrees clockwise, right? So this angle right here, which looks like about a 90-degree angle, right? So it gives us this 85 degrees. That means that this angle would be 85 degrees. And this angle that they said was about 60 degrees would be this angle, which should be about 60 degrees. And that means that our missing angle up here, the pointiest angle, would be 35 degrees. So our missing angle is 35 degrees. So now let's take a look at some side lengths and how we would use proportions to solve a question like this. So this problem says, if these 2 shapes are similar, what is the measure of the missing side length? So we have 2 sides that are similar. So we have this side and this side, right? This figure was dilated, but it looks like it was just slid over. It was a translation. We didn't do any sort of rotation or reflection. They just kind of moved this figure. They made it bigger and they moved it over, right? So I would look at the corresponding sides. So I know that this side, 1, corresponds to this side that is 3 feet. So I know that 1 corresponds to 3. So that means that this side length, h, corresponds to this side length that is 6 feet. So h corresponds to 6 feet. So the way that I would read this is 1 is to 3 as h is to 6. And that's how I would set up this general proportion. And I would solve this using something similar to the butterfly method, if you've heard of that. But basically all I do is I take the numbers that are diagonal from each other and I multiply them. And then I take the last number and I divide my answer by that number. Sorry, okay. So I would do 1 times 6, which is 6, and then I would divide by 3. You can use whatever method works for you. So 1, and that would give us 2. So h is equal to 2. Okay? And you can kind of see that because here we multiplied by 3, right? So 1 times 3 is 3, so 2 times 3 is 6. So obviously there's a scale factor of 6, right? The scale factor for this dilation, I'm sorry, it's not 6, it's 3. We multiplied by 3, we multiplied by 3. But they're asking us for that missing side length, so that missing side length is 2. And let's take a look at one more like this. So very similar, they dilated this pre-image to get this new image. They made it bigger, so the scale factor is definitely greater than 1. And let's see what we did here. So it looks like we can just take a shortcut, right? If we went from 1 to 4, well, what did we multiply by? We multiplied it by 4, right? So now we're asking ourselves, well, what number times 4 will give us 8? Well, the answer again is 2, right? 2 times 4 gives you 8. But let's just set up our proportions again, just because the numbers won't always be so easy. All right, so let's just take a look, and we know that, let's use 2 different colors. We know that this side and this side correspond to each other in yellow, and we know that these 2 sides in blue correspond to each other. So if we set up that proportion, we know that 1 foot is to 4 feet, as x feet is to 8 feet. And you want to always make sure you're going in the same direction. So my numerators are the numbers from our pre-image, the purple triangle, and my denominators are from my image, my bigger triangle. So we set that up and we solve using whatever method works for you. I'm just going to multiply the numbers that are diagonal from each other. That'll give us 8. And I'm going to divide by that last number, and that'll give us 2. So we still got the same answer, right? But it's always more precise to use proportions than it is to just guess, because it's not always going to be a nice, easy scale factor that's like a whole number integer.